Hi, in this video I'm going to be talking about a quick introduction to exponential equations, and the graphing specifically is what we're working on here, the graphing of exponential equations. And when we say exponential equations, what we're doing here is we're going to move the x around, and we're going to make a function that relies on x as its variable. And this time, instead of being like x squared or x cubed or x to the fourth and all the crazy stuff we've been working so far in this class, we're going to take a number and we're going to raise it to the x power. The x is going to go up in the exponent. So I can put whatever number I want to here, maybe like a 3 or something, okay? That would be an example of an exponential equation because now the x is in the exponent. And what does that do? Okay, that's what we want to figure out. The big idea here, okay, at every single graph that we've had so far this year, so like for instance, we had parabolas, right? And we graphed parabolas, we said the most important point on that graph was the vertex. It's right here, okay? And when we did cubic equations, we said, okay, we get this S-curve that comes in nice and clear with the cubic equation, and the most important point was right here in the middle. Well, the most important point with an exponential equation has to do with raising something to the 0 power. That's pretty simple. For instance, if I put in a t-chart here and I wanted to plug in some values for x and y, and I wanted to start with 0 perhaps, I know this, that no matter what power I'm raising, or number I'm raising to the x power, no matter what this base is, we call that the base, okay? And we call this the exponent. No matter what the base is, whether it's 3 or 5 or a billion, if I raise it to the 0 power, it's going to give me 1. 5 to the 0 power is 1. 1 billion point that raised to the 0 power is 1. Everything raised to, you know what, you can even do negative numbers. Negative 700, you know, all that stuff raised to the 0 power, oh, it's negative 1, okay? Because I put a negative sign outside the parentheses. Let's do it this way. If I include the negative sign within that, okay, that raised to the 0 power is 1. Okay, this actually did the negative sign after it raised it to the power. That's why I got a negative 1 out. So be careful about that. Obviously, parentheses are going to be important in this chapter, just like they were in every other chapter. Okay, but if I put a 0 in for x for 3 to the x, I get 1 out. And so if I graph 0, 1, there is my important point on this graph. Now it's a matter of just knowing how to raise 3 to a certain power. So if I put in a 1 for x, now I'm talking 3 to the first power is just 3, right? So 1, 3 would be the next point. And if I put a 2 in for x, that would be 3 squared, 3 to the second power, and that is 9. And so you can see that the rest of these are going to depend on whatever the base is, right? But I don't care whatever I get. Whenever I have a 0 in the exponent, I get 1 out of the function, okay? Now here's the interesting thing is what happens if I put in a negative number, because we can see that we start to have a curve upward and it's going to do this, and the next one would be 27, and then it'd be 81, and then I'm going to multiply by 3 every time. It's going to get 3 times higher, right? What happens if I put a negative 1 in? Well, that would be then 3 to the negative first power. I'm going to write it down here for the sake of space. What is 3 to the negative first power? If you remember from our rules of exponents that we did last chapter, I can take that, I can move it to the bottom of a fraction and call it a positive first power, right? So that's just 1/3. Let's see if that corresponds with what we see on the calculator. 3 raised to the negative 1 power would be 0.3333. That's 1/3, isn't it? I can do math fraction if I want to turn it into 1/3. So this is 1/3. So it's going to be like, I don't know, what do you think? About right there, negative 1 and 1/3. And if I do negative 2 power, what is 3 raised to the negative 2 power? Well, that's the same thing as flipping it to the bottom of the fraction and calling it a positive 2. That would be 1/9. So negative 2 gives me a 1/9, which is going to be like right there, you know, pretty darn close. Let's go all the way out to negative 10. Let's see what happens when I put a negative 10 in. Okay, what is 3 to the negative 10th power? Well, that's 1/3 to the positive 10th power, and 3 to the positive 10th power is 59. Geez, this thing is 1/59,000th. Well, here's the crazy thing. That's still above 0, isn't it? So it's like right above the axis, but it's still there, isn't it? And so we see an interesting property develop, and what happens is this line here, right there, it approaches 0, but doesn't touch it. And we're going to deal with that in a second video, okay? The main thing here is I want you to understand, before I shut off this video and go to the next one, that an exponential equation means x is going to be in the exponent. When I graph an exponential equation, the most important point right there is 0, 1. Why is that the most important point? Because if I put a 0 in for the exponent, it's going to be 1, no matter what the base is, 3 to the 0 power in this case. For plotting points, it's simply a matter of multiplying by 3 every single time because that's the base, or dividing by 3 every single time because that's going to be what I do with the negative exponent, right? So I can quickly and easily plot some points, and I figure out here that I have an exponential equation that goes upward. In the next video, what I'm going to do is I'm going to talk about what happens if that's a negative value or what happens if this is a fraction. We're going to talk about a concept called exponential decay as opposed to exponential growth. Growth here meaning that it's going upward as x gets bigger. Hopefully that makes sense. Look for the second video here in just a second.